All right. Looking at the nature of matter, we're going to look at matter and the chemistry behind matter. Now, first of all, what is chemistry? Chemistry is the study of the properties, nature, characteristics, and structure of matter. That's what we do in chemistry. And matter is any substance, please take note, matter is any substance that have mass. So for you to be matter, you have mass and you will occupy space, and space is known as volume. Space is known as volume. So matter can be said to be anything that have mass and occupy space, which is called volume. Yes. Now quickly, looking at other ways to define matter, we can say matter can be anything that have mass and volume, and mass over volume, mass over volume, mass over volume is equal to density. Mass over volume is equal to density. So we can say matter is any substance that have density. So any substance that have density can be defined as matter. Yes, matter is any substance that have density. So matter can, in chemistry, basic chemistry, can be considered to be the following. Now, basically, matter can be considered or classified into the following. So this is the definition of matter. These are the characteristics of matter. So matter can be the following. Yes, matter can be pure. This matter can be a pure substance. Matter can be a pure substance. And matter can be an impure substance. What is an impure substance? Impure substance that we have is the mixture. So when we say matter is an impure substance, we mean a mixture. Matter is a mixture. Now the pure substances are um elements and compounds. So the pure substances are elements and compounds. The pure substances are elements and compounds. Now, we are going to, before we look at the classes of matter thoroughly, we are going to quickly, before we look at the classes of matter thoroughly, we are going to quickly look at the properties of matter. Now, the properties of matter, before we look at the classes can be pure and impure. So, the properties of matter. Now, the properties of matter include intensive. Properties of matter includes one, intensive properties, and the second one is extensive properties. Intensive properties, and the second one is extensive properties. Now, what are intensive properties? Intensive properties are properties that depend on the quantity of matter present. So intensive properties are properties that depend on the quantity of matter present, while extensive properties are the properties that do not depend on the quantity of matter present. So extensive properties are those properties that do not depend on the quantity, or rather, I think I did an opposite explanation. Pardon me. Now, intensive properties are the properties that do not depend on the quantity of matter present, while extensive depend on the quantity of matter present. So, pardon my bad, intensive properties are properties that do not depend on the quantity of matter present, while extensive properties are properties that depend on the quantity of matter present. Now, intensive properties include this general classification. We can say these properties are physical properties. Consider these properties are physical properties and chemical properties. Yes, so these properties are physical properties and physical properties such as color, texture, and so on and so forth. Chemical properties such as the reaction with go, addition of water, reaction with a base, reaction with an acid, reaction with a metal. Those properties don't depend on the quantity of matter present, in the sense that if a substance can react with water, 1 gram of it or 0.5 gram of it should be able to react with water. So its intensive properties do not depend on the quantity of matter present. Extensive properties depend on the quantity of matter present. So extensive properties include, e.g., their mass. Yes, mass depend on the quantity of matter present. Another very important one is volume. Yeah, volume. It depends on the quantity of matter present. Yeah, volume. So volume depends on the quantity of matter present. So mass, volume, and so on and so forth. Those properties are said to be extensive properties. So I'll quickly look at the classes of matter. I've been looking at the properties. Before we look at the classes, let's look at the changes of matter. Yes, the changes matter can undergo. Yes, the changes matter can undergo. Now, changes of matter. So changes of matter. So changes of matter include, we can just quickly say there are three main changes matter can undergo. But basically, in our whole level chemistry, we leave it at two. So I'll talk about two. So they are the physical properties, or pardon me, the physical change, the chemical change, physical change, chemical change, and nuclear change. And nuclear change. So these are the changes matter can undergo. So physical change, chemical change, and nuclear change. What is a chemical change? A chemical change is a change that does not lead to the formation of a new substance, does not lead to the formation of a new substance, and it is easily reversible. So physical changes do not lead to the formation of new substances, and they are easily reversible. E.g., for instance, we have melting of ice. Melting of ice. Now, there's a compound we call zinc oxide. Yeah, when you eat white zinc oxide, it is white at room temperature. Eating it and becomes yellow zinc oxide. Now, such change, eating zinc oxide from white to yellow, eating from white to yellow, the zinc oxide is not changing in composition. That is what we call a physical change. And it should be noted that all change of state of matter, so I'm talking about state of matter, all change of state of matter are physical changes. What I mean by change of state of matter? So let's say the state of matter now. State of matter. State of matter primarily can be four. The four primary state of matter. We have solid, liquid, primary on earth, and plasma, solid, liquid, gas, and plasma. So each of the states are interconvertible to each other. Yes. So from solid to liquid, let's call here A. From solid to liquid, the process is melting, or what we call fusion. Yes, melting or fusion. Solid to liquid is melting or fusion. While from liquid to solid is known as freezing or solidification. Yeah, so from solid to liquid. So B is freezing or solidification. Then from liquid to gas, C is termed evaporation or vaporization. Though evaporation is a surface phenomenon, what I mean is that evaporation occurs at the surface of a liquid, while vaporization occurs throughout the liquid. Another difference between evaporation and vaporization is that evaporation occurs at any temperature, vaporization occurs at boiling point. So when you see sun, for instance, sun, for instance, acting on water, or you expose water to sunlight, now you observe that some of the water particles will be evaporating. Yeah, that is not vaporization, that is evaporation, because it is not yet the boiling point of water. So vaporization occurs at boiling point, evaporation can occur at any temperature. So let's say this gas to liquid back, so gas to liquid back is D, gas to liquid is D. So the process of converting gas to liquid is called condensation. These are changes of state of matter. And remember, this change of state of matter, freezing, um, freezing, melting, evaporation, vaporization, condensation, they are all physical changes. Now, a new state of matter to many of my viewers will be the plasma. Yes, a new state of matter to many of us will be the plasma. Now, what is a plasma state of matter? Plasma state of matter, plasma state of matter Um, it's and a typical example is fire. Yes, plasma state of matter. A typical example is fire. Now, fire is in the plasma state of matter. So when you see things burning, usually in the plasma, the sun is in the plasma state of matter. To convert gas to plasma, the process is called ionization. So converting gas to plasma is called ionization. So that's why plasma is sometimes called ionized gases. Then to take plasma back to gas, we deionize. So gas to plasma is ionization. Plasma back to gas is deionization. Now, for chemical changes quickly, there are changes that are not easily reversible. It doesn't mean they're not reversible because we have a reversible chemical reaction. There are changes that are not easily reversible, but they lead to the formation of a new substance. So changes that are not easily reversible but leads to the formation of a new substance is known as a chemical change. A typical example of chemical changes is exposure of white phosphorus in air. When you expose white phosphorus to air, expose white phosphorus to air, at the end of the day, phosphorus will take oxygen in air and become P4H10 or P4O10. Yes. So phosphorus more like combusts in air or burn when exposed to air, white phosphorus. So this type of change, this white phosphorus exposing to air takes oxygen and it turns to phosphorus 5 oxide. So this is a chemical change, exposing white phosphorus to air. Rusting of iron. Rusting of iron is a chemical change. Burning of wood. Now, those are chemical changes. They lead to the formation of new substances. Now, the last one is the nuclear change. The nuclear change is a change that is not very common to our O-level chemistry. It's actually a change of state of matter. This is the change that leads to the formation of, or it is a change um, most what's it called? Well, like I said, most nuclear materials or most radioactive elements such as um, radium, these are the changes they undergo. Now it's a change that it is not reversible in any form. Ordinarily, it is not reversible at all, and a new substance must be formed. It is not reversible. It is irreversible if there's any word like that, and a new substance must be formed. And if you look at the composition of the matter, it is initiated by the nucleus of every matter. It is initiated by the nucleus of every matter. That's why it is called nuclear change. That's why it is called nuclear change. So those are examples of the changes of state of matter and the states of matter. So these are a brief introduction to matter. Remember, matter is anything that have mass and occupies volume, or we can say matter is anything that have density because mass ratio volume is density. And then we looked at the changes and the states. Subsequently, we'll look at the classes. But before we leave, I'd like to quickly talk about the classes of matter and just quickly define them. So the class of matter is I classified them earlier. Matter can be classified into pure and impure substances. And I said the pure substances, the pure substances are the pure substances are the pure substances are the pure substances are the elements. The pure substances are the elements. Pure substances are the elements, compound, and mixture. Element, compound, and mixture. Pure, please take note to, pardon me. This is pure. Then the mixture is totally impure. The mixture is impure. So let me quickly define them and give you an example. Now, the element is a substance that can not be split. Yes, an element is a matter or a substance or is matter that cannot be split into ordinary chemical that cannot be split into simpler units, cannot be split into simpler units by any ordinary chemical process. So an element is a substance that cannot be split into simpler units by any ordinary chemical process. So if I have an element sodium cannot be broken down to any other element to any other element by any ordinary chemical process except you use a nuclear process. So chemical changes can break down elements further. So elements are given symbols, and that idea was given by J.J. Berzelius. So J.J. Berzelius, Jacob Jones Berzelius in 1814 was the first to say we should start representing elements with symbols. Though the first definition of an element was given by Robert Boyle and traditionally talked about by Robert Boyle, but in literature was the definition of an element was accredited to Lavoisier. So a compound on the other hand is a combination of two or more elements. Remember, elements are represented with symbols. Yes. So for instance, let's say this symbol, let's say let's say I have sodium and chlorine. So these are symbols. Sodium is an element, sodium, chlorine. Now these are elements. Now these elements, when they combine, when they undergo a chemical change or between these elements there's a force. So a combination of two or more elements chemically is a compound. And compounds are represented with formulas. So the formula NaCl will be sodium chloride, a compound. H2O. So they are represented with formula. So the combination of two or more elements, chemically, it's a compound. What about the mixtures? Mixtures, remember, they are impure. Now they are impure because a mixture is a combination of any of the elements or compounds. So I can say element and element, or rather we can say a mixture is a combination of two or more pure substances and there is no chemical combination. So a mixture is the physical combination of two pure substances. So the physical combination of two pure substances is a mixture. Yes, the physical combination of two pure substances is a mixture. Are you getting that? So element, compound, element, compound, they have a mixture and they are physically combined. What I mean is that they can be easily separated. Remember, a physical change can be easily reversed. So if I have a mixture, I can easily separate the mixture. So example of mixture is sand and water. So I have H2O and sand. Sand is a compound called silicon oxide, SiO2. Yes, silicon oxide is sand. So I have a mixture of sand and water, for instance. I can easily separate it by various techniques, and these techniques are known as separation techniques. So sand and water, I can easily separate them using filtration. I can have salt and water also. Salt and water, common salt and water. Sodium chloride is common salt. So common salt and water can also be easily separated. Yes, common salt and water can also be easily separated by a technique known as evaporation to dryness. So in our next video, we'll be looking at how to separate mixtures, and the process used to separate mixture is known as separation techniques. Until we see next, it's a bye. So please like, and if the video was helpful to you, don't forget to always like and subscribe. So I'll